This is part 3 of our lesson on graphing and analyzing rational functions. Alright, when I use that phrase rational functions are fractions that are made out of polynomials. Alright, number 3 is kind of tricky, so be careful. Normally I zoom right in on the denominator and I ask myself about the vertical asymptote. And I'll say to myself, oh look, x minus 2. Alright, that means I'm going to have a vertical asymptote at x equals 2. Yay! But slow down. What if this cancels out with a factor in the numerator? If it cancels out, it's going to be a whole and not an asymptote. So I really should always be checking to see if this factors, and specifically if it factors and makes the same factor as the denominator, because that's what's going to happen on this problem. So this is going to factor as, okay, so x squared is x times x. 6, among other things, is 2 times 3. And to make a positive 1 middle, we'll need a negative 2 and a positive 3, which also gives us negative 6. But as you can see, that factor matches the factor in the denominator. So those are going to cancel out. And when a factor cancels like that, it means it's not going to be an asymptote after all. Instead, that's just going to be a whole. So this tells us that we will have a whole at x equals 2. I'm still setting this equal to 0 and solving. That's why I'm getting x equals 2. Alright? Because look, now that those x minus 2's canceled out, all we have left is this x plus 3. Okay? And this is, think of it as y equals x plus 3. You know, f of x equals x plus 3. This is a diagonal line. It's like y equals mx plus b. Okay, so that's what we're dealing with. But you still can't divide by 0 even if it cancels out. So x cannot be 2. So anyway, there will be a whole at an x value of 2. So that means 2 comma something. Now what will be the y value to go with it? Well, y is equal to x plus 3. So in this case, that means y is equal to 2 plus 3. Okay, so obviously that means y is equal to 5. So that's the y value that goes with it. So there'll be a whole at 2 comma 5. You should show that as an open circle. So 2 comma 5, put a nice clear open circle for the whole. Okay, now the rest of this is just going to be a line. Like I said, it's y equals x plus 3. So we don't have to do anything fancy. We don't need a table of values or anything. That 3 tells us to start at the that's the y-intercept of 3, and then this slope is 1, so that's like up 1 over 1. So that would be like this, and there's the whole, of course, and you can just continue that pattern to the edge of the graph and do the same thing in the other direction. Okay, so we'll go ahead and graph this thing. Okay, but when you do it, you should be sure to stop on either side. Leave this hole nice and empty. I can sort of cheat by making a white circle, and then that white circle will sort of cancel out anything that you could see there. In fact, if I'm going to do that, I don't really need the blue anymore. Isn't that pretty? Okay, so make sure your hole is nice and empty like that. So that's the graph right there. There are no asymptotes or anything. It's just a line. Okay, so the domain, if it weren't for the hole, the domain would be negative infinity to positive infinity. But because we have this hole in the graph, we have to split the domain up. So the domain is x values. So it's negative infinity to 2, and then 2 to infinity. Union to infinity. That's the domain. Alright, obviously you can't include the 2 in the domain because it's a hole, so that's why the parentheses. Now the range is y values, bottom to top, so negative infinity to 5. This is a y value of 5 up here. Okay, so negative infinity to 5, and then 5 to infinity. Okay, vertical asymptote, there was none. Alright, normally it would have been a vertical asymptote at x equals 2, but it canceled out, so it's a hole instead. There's no horizontal asymptote either. Well, we knew that anyway because the top degree is higher. But normally we would go, oh look, the top degree is exactly 1 higher. Alright, in general we have this rule that if the degree of the numerator is 1 greater than the denominator, then you're going to have this slant asymptote. But if you were to accidentally do the long division, you would see that there was no remainder. There has to be a remainder. In other words, you just have to make sure that it doesn't cancel out. If it cancels out, all bets are off. There's no asymptote when all you have is a straight line. A straight line does not have an asymptote. Okay, so slant asymptote, none. There is no slant asymptote. It's just a line. We had a hole at 2, 5. X-intercept, well, it clearly touches the x-axis at negative 3, 0. Y-intercept crosses the y-axis at 3, 0, 3. Increasing intervals. Well, it's increasing over the entire graph, but because of the hole, we have to break it up into 2 parts. Alright, you can never include the hole in your interval. So it's increasing from now we're doing x values now, so I'm going to call this negative infinity. Alright, but just to be clear, that was an awful negative infinity. Let me try that again. I'm going to call this negative infinity, but not because it's going down, because it's on the left. So negative infinity to 2, okay, because we're only doing x values, and then we'll say 2 to positive infinity. Again, not because it's going up, but because it's on the right. Okay, so it's increasing from negative infinity to 2, and then it's increasing some more from 2 to positive infinity. Alright, it's increasing over its entire domain. Just had to leave out the hole. Oh, okay, this got cut off, but decreasing interval, yeah, there wasn't one. Can I make this wrap back around? It's bothering me. That's better. Decreasing intervals, there are no decreasing intervals, none. Alright, it's all increasing. Okay, that is it for problem number 3. Alright, that was relatively fast. So we can do another problem instead of just one problem per video. Yay! Let's definitely factor first. Obviously things can factor here, so let's do that before we get carried away. So this is going to factor, and this is going to factor. This is the easiest, so let's get that done. So this will be x plus 3 times x minus 3, difference of two squares. Okay, this up here, x squared, we're talking x times x, 20, 4 times 5 is 20. I know the middle needs to be negative 1, so that means positive 4, negative 5, and that does make negative 20. Positive times negative is negative. Does anything cancel out? No, nothing cancels out. So that means there won't be any holes. No holes. Okay, but it was important to check that. So that means these two factors in the denominator will give us vertical asymptotes. So I will have a vertical asymptote at x equals negative 3. Okay, please understand that the x plus 3 is giving me x equals negative 3. Alright, similarly there will be another vertical asymptote at x equals positive 3. It's coming from that one. Alright, so we've got these two vertical asymptotes, negative 3, positive 3. Looking like that. Okay, so what about horizontal asymptotes? Okay, look at the degree. The top degree is 2. The degree of the denominator is also 2. So if we look at the rules for horizontal asymptotes, we find that if the degree of the numerator is equal to the degree of the denominator, then that's when the horizontal asymptote is y equals a over c, where the a and c are the leading coefficients. Okay, so what are the leading coefficients? Well, it's the invisible 1 and this other invisible 1. So there will be a horizontal asymptote, and it'll be y equals 1 over 1, which is just 1. So horizontal asymptote at 1. So that's going to look like that. Okay, you can't have a horizontal asymptote and a slant asymptote, so slant asymptote, none. Okay, nothing canceled out when we factored it, so there won't be any holes, so none. X-intercept, y-intercept. The x-intercepts you can get by setting the numerator equal to 0. Okay, so the numerator, if I set this equal to 0, really it's like I'm setting both of these equal to 0. So I'm going to have x-intercepts of negative 4 and positive 5 if I solve those little mini equations. Negative 4, positive 5. Okay, so these are x-intercepts. So when I say negative 4, it's negative 4 comma 0. And positive 5 is positive 5 comma 0. Alright, might as well graph those x-intercepts. Okay, make it purple. So there's an x-intercept right there at negative 4, and there's one over here at positive 5. Okay, x-intercepts. Okay, what else? Oh yeah, y-intercepts. Well, the y-intercept will be what you get when x equals 0. Alright, so if we go back and let x equal 0, what happens? Well, if x equals 0, that means this is 0, not 10, but this is 0, and this is 0, and this is 0. So, hold on, I'm hiding the sign here. It's a negative 20. So, basically, everything that has an x in it goes away when you make it 0. So what you're left with is the you got the constants. So we have negative 20 over negative 9. Okay, negative times negative is a positive, so that's 20 over 9. So that's the y-intercept. Okay, is 0 comma 20 over 9. Okay, might as well look at the decimal form of it. 20 divided by 9. That's 2.2. Okay, so you have a y-intercept at 2.2. So that'll be right about here. Okay, all those points are very helpful. So now it's time to make a chart. See what we're dealing with. Okay. Alright, thanks to the x-intercepts, we already have a couple of values to the left and to the right. So we really need to look at what's going on in the middle here. Alright, so I would love to see what's going on at, what's going on at, for example, -2 and -1. Let's definitely check that out. And what's going on at 1 and 2. Okay, don't be stingy. The more points you have, the better. Okay, so those are several points here in the middle. Just for fun, let's go ahead and take a look at what's happening at 4. Okay, because I think that could be helpful. Alright, I think that'll give us enough information. So let's go back and use our calculator to help us out. Alright, we're just going to put this in the table feature. Alright, so you hit your table button, get rid of that old thing, fraction mode. So we have x squared minus x minus 20. So that's x squared minus x minus 20. And then the denominator is x squared minus 9. Alright, so that's going to be x squared minus 9. Okay, so I want to know what's happening at -2, so that would be a good place to start. -2. So at -2, we got 14/5. I'm going to toggle it 2.8. Alright, how about -1? Well, that's 9/4, which is 2.25. Alright, and how about at 1? At 1, we have 5/2, which of course is 2.5. Okay, how about at 2? At 2, we have 18/5, which is 3.6. And what about at 4? At 4, we have -8/7, which is -1.1. Alright, let's plot these points and see where we are. Okay, so at -2, we got 2.8. So here's -2, and here's 2.8. It's almost 3. Alright, at -1, we're at 2.25. So -1 is 2 and like a quarter. Okay, at +1, we're at 2.5. Okay, so that's up a little bit higher. At 2, we're at 3.6. So there's 3.6. It's right about there. Okay, and at 4, we're at -1.1. So at 4, we're at -1.1. It's basically right there. Okay, so that should be enough information to show us what's going on. So obviously, it's curving towards the asymptotes like this. So let's see. So let's graph this thing. So it's doing something like this. Alright, and curving toward the asymptote. Okay, it's always got to curve toward those asymptotes. And then we have some branches over here. So it's going to be doing this type of thing. And it's going to be doing this type of thing. Okay, so your graph should look a lot like this. Okay, what else do we need? So domain and range. So this graph goes left forever and right forever, but it skips the two vertical asymptotes. So we will have to do the domain in three parts. So this first branch is from negative infinity to negative 3. Okay, so it'll be like this. It'll be negative infinity to negative 3. So then we got to skip the negative 3. So we'll go union. And then it'll be negative 3 to positive 3. Get rid of this. In fact, I can get rid of all this now. Okay, and then, alright, so that was the middle part, from negative 3 to positive 3. And then the third branch is from 3 to infinity. Alright, notice I'm using all round parentheses because these are asymptotes. We're trying to skip them. We can't include them. So you have to use parentheses. Okay, let me get rid of some of this clutter as well. Gotta clean up my house, my digital house. Now the range. Okay, the range. This lower part down here. So the range is the y value, so bottom to top. Obviously, both of these branches go down to negative infinity. For the range, because we're doing y values, we will not treat these separately. Both of these branches are covering the same y values simultaneously. So I won't have a statement for this one and a statement for this one. So the function as a whole covers the Control Z. The function as a whole covers y values from negative infinity up to 1. Okay, see where the asymptote is? So negative infinity up to 1 is our first part of the range. Okay, negative infinity to 1. Now that's an asymptote at 1. That's an asymptote there. So we're going to leave that round parentheses. Union. Okay, now it doesn't pick up right at 1. So we're not going to go 1 to infinity because there's a gap here. There's nothing going on between 1 and 2. Okay, so the next branch picks up the y values go from 2 to infinity. And this 2 is not an asymptote. It's just a regular point. Okay, so it touches it. So we will use a square bracket to show that it is included. So 2 to infinity is the rest of the range. Okay, now let's talk about increasing and decreasing. Okay, so we'll just go left to right, and we're talking about x values. So as we travel this graph from left to right, this first branch from left to right is going down, 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 down. Okay, it is decreasing. Okay, and then it picks up right here, and again it's going down, 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 down. It's decreasing, at least to right here. And then it changes directions and it starts increasing from here to here. Alright, so it's decreasing, then it was increasing. And then it jumps and picks up here. And then it's increasing. Alright, uphill, uphill, uphill. And look, it's increasing for the rest of its life. Alright, so everywhere that you see pink was a decreasing interval. Everywhere you see green was an increasing interval. Okay, so we have 2 increasing and 2 decreasing intervals. Now, please focus on the x values. Increasing and decreasing intervals are always x values. So over here, look at this end of the pink zone. The x value is negative infinity. Okay, because of the way it goes to the left forever. Look at this end down here. Look at this. Okay, the x value is the asymptote because it's getting closer and closer to this vertical asymptote. So the x value here is negative 3. Okay, similarly, this end right here, alright, the x value is negative 3. Again, because of the asymptote. Right here, the changeover from decreasing to increasing, the x value here is 0. Okay, because that was our y-intercept. And then this end of this green branch over here. And don't say positive infinity, alright, just because it's pointing up into the sky. We are talking about x values. The x value over here is positive 3. Okay, let's look at this end right here. Alright, this end right here, again, it's the asymptote that matters. And that's an x value of 3. And then finally this end over here. Okay, x values, it goes to the right forever. So the x value is positive infinity. So I will use these blue x values that I thought about very carefully, but now I will just look and go, oh, this one, negative infinity to negative 3. So let's see, what do they ask us for first? Increasing intervals. So we have 2 of those. We have our first increasing interval is from 0 to 3, x values. Alright, 0 to 3. Okay, and we will leave them round parentheses always, because right at the changeover, 0 is where it changes from decreasing to increasing. But right at 0 it's neither, so it's not to be included. We have another increasing interval from 3 to infinity, x values. Okay, and decreasing intervals were the pink zones. So negative infinity to negative 3. And then we had another one from negative 3 to 0, x values. That's why it's negative 3 to 0, it's x values. Okay. Alright, this video is getting long, and so we will definitely stop it here. So that does it for problem number 4. Okay, we will pick up the next video with problem number 5, where we ask some general questions about rational functions. We speculate and imagine.